Okay, so here we have a definition of a convergent sequence and also a definition for a divergent sequence. Okay, so basically if the sequence approaches some real number, one real number, then the sequence is said to be convergent. Any other situation gives a divergent sequence. Okay, let's maybe want to pause the video actually and digest that for a moment. Okay, let's move on to an example or two. Okay, A. Okay, AN is, starts with -1, then 1, then -1, then 1, then -1, then 1. Okay, it does not matter how large I take n to be. The sequence is not approaching anything, right? It's just oscillating between -1 and 1. So here we'd say divergent, and maybe in brackets here we'd say two L's, why not? Oscillating. If you don't want to say oscillating, you can say alternating. So it's alternating back and forth, -1, 1, -1, 1. So it doesn't approach anything. Okay, there is no number L that the terms here are getting closer and closer to. Okay, B may appear at first blush to be similar, but there's an extra thing happening here. Okay, you get plus or minus 1 on top, right? But then, you have these denominators that are getting larger. So what's happening here? Well, it appears to be approaching 0. That's my first idea here. And we can prove this by just saying that, well, -1 to the n is between 1 and -1, right? So therefore, -1 over n is less than or equal to -1 over n, or -1 to the n over n, oops, less than or equal to 1 over n. And on both sides, we have limits is equal to 0. So therefore, we conclude that this sequence goes to 0, too. And we are using, yeah, you guessed it, this is a squeeze theorem. For sequences. Okay, I imagine this is in your textbook, 11.1. So what is it saying to us? It's saying that the limit here is 0, and the limit here is also 0. So this guy here in the middle is being squeezed between those two, and must therefore approach 0 as well. So we call this squeeze theorem. Okay, let's try some more examples rather. More complicated maybe. Root n and b something complicated, 2 to the 3 minus 2n, 3 to the n. So I guess the question here is convergent or divergent. Okay, so for our first sequence, we obviously get an is not bounded, it's approaching infinity. So this is divergent, okay, because infinity is not a real number. B, we're going to have to do some algebra here to see what's happening. So what am I going to do? Well, I'm going to deal with that, well, this negative exponent that appears here. Okay, so bringing it downstairs makes the exponent positive. And then what do we get? h.3.3n. This is 4 to the n. So overall, we get 8 to the 3 over 4 to the power of n. Okay, now that we have it nice and simplified, we can ask ourselves, what's happening to this expression as n gets larger and larger? We have a1 is going to be 8 times 3 over 4 to the 1, which is 8 times 0.75. So you can think of that as, think of this here, as 75% of 8. And a2, okay, you're going to get 75% squared though, right? So you get that 0.75 appearing twice. Okay, so here we have 75% of 8, and then we're taking just 75% of that. So we're getting even smaller, right? Anyways, all this together, we conclude that an is actually going to go to 0. Okay, more precisely, what I'm saying is that you can make an here as small as you want just by choosing this n up here to be large enough. Okay, so if I want an, if I want, this, if I want this expression to be, 10 to the negative 13, something tiny, okay, it's going to be possible to find an n that will do that for me. Okay, anyways, altogether we see that an is going to 0. Okay, perhaps to summarize, r to the n goes to 0 if and only if r is between -1 and 1. Okay, so write that down. That's going to be something we use over and over and over again. And now for an exercise to conclude our video. What do we got? find the limit or explain why the sequence is divergent. A. An is equal to root n over n. B. A to the n is equal to 6 to the 1 minus 2 n 2 to the 5 n minus 1. And answers, well, why don't you pause your video, give these a try. The end, pause them now, pause. Okay, answers are 0, or we'll say, lim root n over n is equal to 0. B, lim, well, I don't want to write that again, so I'll just write lim an is going to be 0 again. Okay, looks like I get 32 over 36 or some such. And I want you to notice one last thing. Okay, with limits of sequence, we just write limits. We don't write limit n goes to infinity. Okay, because when you're talking about a sequence, it's always n goes to infinity. So typically, we just drop the n goes to infinity bit and just write this.